everyone. And after wonderful inauguration, wisdom words by Mr. Sudheer Kumar and then presentation by Professor Jaydeep, and I think all the people I will just quickly I will go that because my topic is what is the scope for the engineers, signed BSc graduate, MSc, all those people and this thing. So Professor Jaydeep has talked about space tourism. So there is also a scope for research, and in last 10 years our satellites means launch numbers have grown almost 50 times. There is lot of scope for the research and for engineers. He has covered challenges also, that challenges to go to space. So cost reduction in some cases he has shown it has reduced drastically, and we are planning to go to the Mars. So we need a space station on the moon. So that he has spoken. He has talked about mining on the moon. So mining engineers also may be having scope there. So all those things, and he has given fantastic details about comparing moon and earth with all these things. And you see that when we go to space, even suits are important. So I was trying to analyze. He was talking that lot of dust and that is speed, all that, and when space shuttle goes, all that, so speed also something, if I remember, 25,000, 26,000 miles per hour. So then all the things, wear and tear, wear resistant properties are important in all the aspects. So that is important. So we have lot of scope for engineers, graduates in science, for their careers. They can develop in their career in this. So now I will request Venkat to share my presentation, please. Or you want me to share? Okay. You please. Yeah. Can you make full screen? Yeah. So I will be speaking on the current trends in global space exploration, and this thing, what are the scope for others. This thing. Next slide, please. Space exploration, that industry needs, as the Professor Jaydeep also spoke, physicist, astrophysics, chemist, all electronics engineer, all those kind of, so multidisciplinary talents are required. Next slide, please. Now space and human, if we talk, law of science made the invention of rockets to travel to the space. Human, as we said, we are eager that we want to even have tourism in at moon. So humans' hunger created the need to explore the space. I can say almost maybe still maybe 5 or 10%, 5 or maximum 10% we would have explored. 90% is still unknown. So we need to explore that space. And all this, our hunger and our exploration means eagerness, all this word came up, that is space exploration. Space is a boundless three-dimensional extent. This thing, space has millions of mysteries. As we have seen lot of videos in our last presentation, means is someone that astronaut trying to pick up something. We have health challenges, we have bone density. Bone density goes down when we are in the space. So all those things, for all those things, technological developments are required, and we have lot of scope. Next slide, please. Now, when 50 years after this President Obama has told in 2010 that 50 years after the creation of NASA, our goal is no longer just a destination to reach. Our goal is the capacity for people to work and learn and operate and live safely beyond the earth for extended periods of time, ultimately in ways that are more sustainable and even indefinite. So we need water, all that infrastructure also there. And so we have started thinking about for the water, for the oxygen, and when we have done some research on the moon, we could find that some H2 molecules were there. All these things are taking place. So we are beyond of reaching to the moon, and in fulfilling this task, we will not only extend humanity's reach in space, we will strengthen. He has told that we will strengthen America's leadership here on Earth for the space. Next slide, please. Yeah. Space and human, when we talk, advanced developments of exploration systems are there. As we have to reduce the risk, we have to take care of this safety, lower life cycle cost is hidden cost, validate operational concept for future human missions for each beyond each orbit, support that robotic missions of opportunity to characterize the means destinations for human exploration. There are strategic knowledge gaps. There are strategic means knowledge gaps about the knowing about the space, about that dust, all those things that is there. That what is the velocity of that? What is what kind of wear abrasion it creates? All this thing is required. So expand we can say human presence into solar system. That, and from there we are planning to go to the Mars. So then we have started thinking that in next 10 to 20 years we should do advanced exploration. So science is required, engineering is required, and then humanity considerations are required to go to the Mars. So we have started doing all those kind of advanced research. Next slide, please. Yeah. Now there we spoke that a lot of other challenges even that cause, which this was the next slide. Next previous slide. Yeah. So So even Professor Jaydeep also that there are challenges. So going to space itself was a challenge and still is a challenge. Survival in that humans evolved on Earth's surface. Space is a very different environment. Water, oxygen are the challenge there. Then staying and working, doing research, doing mining, going to different places, health, medicine, all these are the challenge, and cost and safety are the challenge. And then I remember when that Rakesh Sharma in 84 went to the space. I am fortunate that our teacher was there, Professor Ramchandra Rao and Professor T.R. Anantharaman. They used to teach us the material science in M.Tech. And that time when Rakesh Sharma from Russia went to the space, then they have done some, when they came back and we were not having even TV in Banaras, so we were listening their interviews on the All India radio in our hostel. They have tried to develop that silver germanium alloy that time. I don't know what happened later on. But then they had processing of ceramics in space. So touring is also our next target. So lack of infrastructure is a challenge. Then biggest challenge is returning back from the space to the earth is the biggest challenge, which we remember that Kalpana Chawla has faced. So where resistance was the biggest challenge when they were coming back. So coatings are required. Next slide please. So when all these things, and when you have heard our previous presentation, we need aerospace engineering to enter to the orbit. We need design engineers, so industrial engineering. We need sensors, we need signals, so we need electrical and electronics engineers to design software and hardware, all those, work out all that strategies for launch. We need computer engineers. We need to choose the right metal, to choose the right alloys. We need the metallurgical engineers to do research in science. We need material science. We need physics. We need chemistry to provide wear-resistant coatings on the shuttle surface and on the engine parts, on bearings, all those things. Advanced ceramic components are required. We need ceramic engineering. This is just, and Professor Jaydeep has covered lot of branches of engineering, lot of branches of science, all that specialization in science. So this is just a brainstorming. So we need lot of field experts. So there is a lot of scope. So next slide please. Now when all these things, engineers are required, space shuttles, although cost have gone down as we spoke in previous presentation. As of now, the global space economy stands at $450 billion. Ever since the exploration of this started in the space industry is growing. Many startups have come up, in public also, private also, and exploiting potential sources. Lot of people have started this. With the participation of more private players, the global space industry is likely to reach almost $1 trillion annual revenue by 2040. This is the Pawan Kumar, that ISRO chairman, has spoken about this, by 2040. Next slide please. Lot of that startups have come up, as the Blue Origin name came in previous presentation also, SpaceX, Virgin Galactic, Agnikul, Skyroot, all this, Dhruva, Galactic, all these startups we have seen, we have listened, and they are working very seriously on this space business. Next slide please. Now if we see that big $1 trillion we spoke, India contributes approximately less than 2% to the space economy of the 1 billion, this thing, which is 20 times less than that of US. Reason that funding is the challenge, cost is the challenge, and we have to, for so many parts, for so many technologies, we have to depend on others. So that is the in India scenario. Next slide, please. Please. Yeah. Now, if we compare the startups in space fields, US in last suppose 10 years, 10 to 20 years, 5,500 startups have come. In UK it is 3,000. In India it is 365 startups. China is less than 300. So this is the startup statistics. Next slide, please. Venkat, next slide. Yeah. So we have lot of job opportunities in space technology, in space technology sectors and startups, and very few people are found experts in this field. And as we heard in the previous presentation, more than engineers, technicians, all those play important roles. I am not trying to say that engineers don't have a role, but they are more important. So next slide, please. Taking time. Yeah. So all these technicians part, even Professor Jaydeep spoke. We need lot of research fellows. He is talking that engineers, all those scientists, they don't know how to write. Write means attractive writing for social purpose. It should reach to the public. So we need all that. We need satellite technologists, biologists, thinking about our health challenges, manufacturing engineers, mechanical engineers, atmospheric scientists, environmental engineering, all this robotic engineering, electronics, aerospace, ceramic, metallurgical, software, computer hardware, astrophysics, astronomer, all that. So aerospace engineering, all those kind of engineers and technicians are required. There is a vast opportunities in this space sector, and what generally in India, I can't say about the US. Generally in India, all the engineers, we think that we take up some software jobs, other jobs, and we don't look even in our professors, teachers. There is a lack that they don't guide to go towards aerospace. So that those are the, we can say, minor challenges. But now I think after that we start that this courses on that explore the space, and then after the presentation of this Professor Jaydeep, I think the students, engineers, whoever are attending will think twice to go to this space. They should think to go to this space. Next slide, please. So, next slide. So, physics, as he has also covered, so I need not talk much. And physicists, that plasma, particle, nuclear, medical, all that, atomic, molecular, astro, all that physics, the Professor Jaydeep spoke in little bit more details. Next slide, please. Next slide. Design engineer, I said, they are important for designing, building, maintaining systems of the spacecraft, launching spacecraft that he has shown in videos also, landing rovers on Mars, building communication satellites, all those. It's so for all the students, it's time for you to look beyond the normal engineering opportunities. We should think, look, search opportunities in space. And space is like a space. So we should think of going to that line. Next slide, please. Yeah. Now if in India we talk that job opportunities, we can think of. National Remote Sensing Center is there in Hyderabad. Satish Dhawan Space Center in there. Bharat BHEL Bangalore, they are working on some space components. Then Vikram Sarabhai Space Center is there in Trivandrum. Space Application Center in Ahmedabad. Then Satellite UR Rao Satellite Center in Bangalore. DRDO is there in Bangalore and so many other places. So engineers can think of looking for the jobs in this here in these all companies or as well as government organizations. Next slide, please. Next slide. Now job opportunity, if we think in suppose private this thing, Skyroot Aerospace in Hyderabad, Secure Analytics in Bangalore, Agnikul is in Chennai, Aeton is in Pune, Pixel is in Bangalore, Astrom Technologies in Bangalore, Space Machines in Bangalore, Mahantasu Space is there in Mumbai, and Bellatrix Aerospace in Bangalore. So all those private companies also have entered into this. So we should think of opportunities to go to even private sector. Next slide, please. Next slide. So you can do even pupil after graduation, they need to do the addresses on the Google, you can go for internship. Next slide, please. Next slide. So with this I am done. I think I have not taken much time. So it was wonderful presentation, inauguration, and means I thank Venkat to organize such a means amazing function, technical function, and there is a good participation from students, even research scholars. So I think next time we will have a further better this thing video, this thing Zoom conference webinar. Thank you everyone and thank you. Bye. Yeah.